Okay, so today we're going to start talking about section 13.1 from your textbook, which is proving trig identities. So today we're just going to talk about manipulating identities and starting to simplify using things that we already know. So first of all, we have to talk about what is an identity. So an identity is an equation that is true for all values of the variable. So we've actually already been using our identities this year. So far in 12.5 we talked about addition and subtraction angle formulas, and then 12.6 we talked about double angle formulas. So these are all identities. They are things that we all know to be true. We actually went through and proved the sine addition formula. And then another one that we've talked about is the Pythagorean identity. So that was sine squared of a value x an angle plus cosine squared of an angle is all equal to 1. So we have that one, we have the sine of a plus or minus another angle, we have the cosine formula for adding or subtracting an angle, and then we have our double angle formulas. So we have that sine of 2x formula and cosine of 2x formula. So those are all the tools right now that we have to work with. So first we're going to focus on how do you start manipulating quantities in trig. So we're going to start by trying to find an identity that has cosine x minus sine x all squared coming from it. So what we're going to do first is we're just going to rewrite what we have. So we're going to write cosine of x minus the sine of x all squared. So then we're going to think, okay, what does having an exponent of a 2, a square, mean? It means to square something, which means to multiply that same quantity by itself twice. So let's write that out. Okay, so now we see two binomials being multiplied by each other. A binomial, of course, is a set of parentheses with two terms in it, one being cosine of x, one being sine of x. And what we want to do now is we're just going to FOIL. So we're going to multiply cosine of x times cosine of x, and we're going to get cosine squared of x. And then we're going to multiply cosine of x times negative sine of x. Can't do anything with that, so we're just going to squish this stuff together. And then we are going to look at multiplying the other way. So we're going to do negative sine of x times cosine of x and get the same thing that we just had. And then we're going to do negative sine of x times negative sine of x. So we're going to get a positive, because a negative times a negative is a positive, sine squared x. Okay, so now all we're going to do is we are going to just rewrite what we already have. So I'm just going to rearrange some stuff. I'm going to put my cosine squared x and my sine squared x together. So I'm going to have cosine squared of x plus sine squared of x. And then here, I see that in the middle up top here that I have a negative cosine sine and then another negative cosine sine, which means I have negative 2 cosine x sine x. Okay, so now we've multiplied, we've combined all of our like terms. We want to see if there's anything that we know we can replace, anything that deals with any of the formulas and identities that we already know are true. So let's look at this right here. We have cosine squared of x, sine squared of x. But on the previous slide, we just said that sine squared x plus cosine squared x is equal to 1. So that's our Pythagorean identity. So we are going to replace this whole term here with 1, because cosine squared x plus sine squared of x is equal to 1. So we're just going to rewrite again what we have. We're only going to do one thing at a time. Nice little baby steps. Okay, so now I'm going to look and see if I recognize anything else, if that relates to any other formulas we know. Well, 2 cosine of x sine of x, that's the formula for the sine of 2x, because if we go off to the side here and remind ourselves, the sine of 2x formula, sine of the double angle, is equal to 2. That's a really bad 2, so let's try that again. So 2 sine of x cosine of x, which is the same thing that we have over here. So again, we're just going to go through and replace, and instead of now writing 1 minus 2 cosine of x sine of x, I'm going to be left with 1 minus sine of 2x. And that's going to be our final answer there. So let's go ahead and circle that, box it out, say that's our final answer. So I know that's my final answer because there's nothing else to break apart. I have a 1, which I can't do anything with, and a sine of 2x, which the only thing I could do with that is break it apart again into its formula, but that would just take me back up to the step right above it. So I know I can't do anything else, which means I am all done.